So for people who have seen the last class, yes, they'll be able to follow it. But otherwise, it's all about areas and volumes which you have done last class. Whereas in this session, we'll go a bit deeper into it. Now, just a quick recap. So when we talk about Simpson's rule, it's used for finding areas and volumes of curvilinear shapes. Now, curvilinear shape means the equation of that shape can be brought under, the formula for that shape can be defined by an equation. But even without knowing the equation, you can still use Simpson's rule, which is why it's a highly simplified form of calculation. Now, with Simpson's rule, we need to first break down the shape with which we are going to calculate the areas or volume into what is called ordinates. So ordinates are nothing but lengths or heights, dimensions basically. So we break down them into ordinates and divide each of them apart by a common interval. Once that is done, we apply the Simpson's rules. Rule number 1, starting from 3 for all odd number of ordinates. Rule number 2, when the number of ordinates are 4, 7, 10, 13, so on. Rule number 3, to be used only when you want to find out the area or volume between any two ordinates, and under other circumstances it is generally avoided because it is the least accurate of all. So is there any doubt what we have done so far?
No, sir.
Fine. In that case, for 13 ordinates, if the number of ordinates are 13, which rule will you use?
Rule 1.
1. Use rule 1 and 2.
Rule 1. 1 first, always preferred.
Yeah. Preferred is rule 1 because rule 1 and 2 both can be used in this case. As I said, 13 ordinates can be done by both, but preferred is rule number 1. So all able to recollect that?
Yes, sir.
Good. So let's get to today's session. Now, Simpson's rule part 2. What we are going to do today is first understanding moments of areas. Now, before getting into the actual Simpson's rule, we are just going to try out with geometric shapes, because that is the first step towards applying these to the curvilinear shape. We will start with geometric shape and then proceed with curvilinear shape. And once we have done all that, at the end we will see sample working also. Right. So first, let's get into proper geometric shape. Let's start with the rectangle. Can you see the dimensions? 12 meters broad, 5 meters high. What will be the distance of its centroid? Anybody? Where will its centroid be? What distance will it be? Don't you think? Yeah.
Half
yes.
of the height, 2.5.
Don't
6
you
meters.
think? 6 meters. Somebody said 6 meters. Both are correct, is it not? 2.5 is also correct. 6 meters is also correct.
2.5, 6.6 meters.
Okay, which means when I had asked the question itself, I need to specify from where. Which means I need to specify the axis from which I want the centroid. So let's go to the next step. Can you see that dotted line at the bottom? Now I am being more specific. So from that dotted line, what will be the distance of its centroid?
2.5.
Perfect. Otherwise, there's a confusion. So unless I specify the axis, it is left unclear. So I have to specify the axis. Any doubt on this one?
No. No, sir.
Okay. Now I have defined the axis. From the bottom, I want the centroid of this rectangle. Sorry, triangle. What distance will it be?
1/3 from the base.
Look at the axis where I want the centroid from, then decide.
So it is 4 meters from the base.
From the base?
From
the
the
reference
dotted
axis.
line, sir. From the
reference
reference axis.
axis. Correct. See, here the centroid is from the apex 2/3, from the base it is 1/3. Is it not?
Yes.
But since I want from this dotted line, the dotted line coincides with the apex. Are you all clear? So what the last answer I got, 4 meters is correct. Is that clear?
Okay, so clear.
All clear on this? So whenever I want any centroid, first I need to decide from which axis, from where I want. Only then I can be very clear on the question. Right. Let's go to the next shape. Now I've gone one step further. I have combined both the shapes. But can you see each one has its own centroid? I'm not interested in that. I want the combined centroid of this whole shape.
8.5.
How did you get that?
6 meter of triangle and 2.5 of rectangle.
So what you have achieved by getting this distance 8.5 is to pinpoint the distance of the centroid of rectangle from the reference axis. 6 plus 2.5, 8.5. Whereas the triangle portion will be from the axis still 4 meters. So this 8.5, do you think will be the correct answer for the combined shape?
Negative, sir.
No.
Yeah, it just cannot be determined simple looks. You have to get into a further details of it. So it is not just possible by guessing it. It has to be worked out thoroughly. So what do you do in that case? Now, what we are going to use is we are going to use moments of areas about a fixed reference axis. That means I'm going to consider these two shapes and I'm going to club these shapes together by moments of areas. Now, the formula goes like this. When I have two different shapes A and B, like what I have here, taking moments of areas about a fixed reference axis, let's say from the bottom of this shape, like the dotted line which I have drawn, area A, which in this case I will take the triangle as shape A. Area of A into the centroid of A plus area of B. B, I take it as the rectangle here. Into the centroid of B will be equal to the total area into the combined centroid. This is what is the moments of areas formula. Now, I need to explain this a bit further. Let's go to the next slide. So we got the two shapes. Shape A is the triangle. Shape B is the rectangle. Independently, we have got the centroid of each. For the triangle, it is 4 meters from the apex, which coincides with the reference axis. Whereas for the rectangle, it is only 2.5 meters, but it is from the base of the rectangle. Remember, it's not from the reference axis. Somebody earlier said 8.5. So if you take the rectangle and I want where is the centroid from the reference axis, it is the total distance 6, which is the height of the triangle, plus 2.5. That is the distance of this centroid of the rectangle from the reference axis. Now going back to this formula, here I have decided that the axis is going to be the bottom of the shape. Yes. So I'm going to take area of A into the centroid of A. Now, can you tell me what will be the area of the triangle?
Uh,
36 meters square.
36 square meters, half base into height. The base is 12 meters, height is 6 meters. So half base into height, 36 meters square. The centroid of A, where is it? How much is it from the bottom? Keep reminding yourself, I need from the reference axis. 4 meters. All clear on this? Let's go to area B. Area B, you need to remember the area will be 60 square meters. All agree on that?
Yes, sir.
Area B is, I'm talking about the rectangle.
Yes, sir. Yes, sir.
60. But remember, I want the centroid of shape B also from the bottom. So I have to take the 6 meters plus 2.5, which is the total height of the centroid of rectangle, 8.5 meters. Are you clear on this? So area is A is 36 into the centroid of A is 4. Area B is 60 square meters into its centroid, which is 8.5 from the reference axis, is equal to total area, which is 96 into the combined centroid. Now, if you take this whole equation, if I take the whole left hand side, are you able to see my arrow?
Yes, sir. Yes, sir.
Whole left hand side of the equation divided by 96 will give you the centroid. All of you clear?
Yes, sir.
Now the whole left hand side of this equation, that is area A into centroid A plus area B into centroid B, that left hand side put together, we call it sum of moments. So sum of moments divided by this total area will give you the centroid of the combined shape. Now do you see the answer which you have got? 6.812. That is the distance of the combined centroid from the bottom. Now, is there any possibility of you having just guessed the answer from this diagram of the shape?
No.
No way. It's not something which we can just come up with so simple. The reason being, the combined centroid depends on the effect of the individual shapes, area and centroid. Both of them have a role to play. How big is the area of A or B? Accordingly, its effect on that whole shape is going to get altered. So that is the reason why it is impossible to just guess it. Clear so far?
Yes, sir.
Any step not clear? It's very, very important to understand this, because unless you are very clear with this, we cannot proceed to Simpson's rule, which is slightly more complex. Any step not clear?
Yes, sir.
Good. Now let's get into this curvilinear shape. First of all, when I want to find the centroid of, let's say, a bulkhead like this, I need to first define the reference axis. So it could be either from bottom or top or anywhere I want. So I have to define that first. So I decided that I want the centroid of this entire bulkhead from the top of the bulkhead, the red dotted line. Now, going back to the previous geometric shape, I am going to take the centroid of each shape from the reference axis. Can you recollect that for moments of
Yes.
areas? Good. I'm going to repeat that same thing, but instead I'm going to do it for each ordinate, because as of now I only have ordinates. I have not combined it by Simpson's rule for getting the whole shape as yet. So I'm just looking at the shape where I only have ordinates. Now let's take the first ordinate A. This red line is the reference axis. What is the distance of the centroid of this ordinate from the reference axis? What is
H
the
by 2.
distance? Distance of ordinate A's centroid. It coincides with the reference axis? Yes or no?
Inline.
Exactly, in line. It's on the same line. So the distance is 0, is it not? Which is what I put on.
Sir, 0.
0, which is what I put here. What is the distance of centroid of ordinate B from the reference axis? Red dotted line.
H.
H. Perfect. And it becomes 2H for C, 3H for D, 4H for E.
Yes.
All of you are clear on this? Any doubts? Now we are not looking at the area between A and B. We are looking at each ordinate centroid from the reference axis. That's all. I'm going to use Simpson's rule to club the shape later, but I'm now looking at centroids of each ordinate. That is all I'm looking at. Clear so far? Can I go to the next part? Now remember this 0H, 2H, 3H, 4H. These are all centroids of the ordinates from the reference axis, which in other words we can call them levers. Levers are nothing but distances from a fixed reference axis, like how we got here. Here you see 8.5, 4. These are all distances from the reference axis. We call them levers. The same happens here for this geometric shape. Now, let's go to the calculation part. A, B, C, D, E are the ordinates. And I use Simpson's multiplier to club them together. That means I'm going to integrate the shape using these Simpson's rule as thumb rule. Simpson's multiplier as thumb rule. So exactly the same what we did last class. The first column what we have here is the product of area, which means Simpson's multiplier into ordinate. So when I add them all up together, what I get at the right at the bottom, we call it sum of product. But since we are going to get one more sum of product here, I call this sum of product 1. This is what we have done in the last class. We have stopped with this. Clear on it?
Yes, sir.
Now I go to the next step. I told you I want the distance of each ordinate centroid from the reference axis. So what was it for the first ordinate?
0.
Ordinate A, 0.
0.
Then it
1.
becomes H, 2H, 3H,
2H.
4H. Now what I have done is, for the sake of commonality, can I call this 0H? Is there any harm in doing so? The first
Yes.
lever.
No.
I can just say 0H. It means the same. Then the second ordinate B, I call it 1H, 2H, 3H, 4H. Now what I get is this entire H becomes common for this lever. Are you all clear on that?
Yes.
Yes, sir.
Now good. What I have done here is, I have taken the entire lever. Instead of multiplying and getting this H common in the last column, I am multiplying this H right at the bottom, once for all in the sum. Is that anything wrong with doing that? Otherwise, remember, I'm going to do it in each case. I'm going to multiply this common interval H, and then I'm going to add it. Instead, I don't do it here. I do it once right at the end. Is there anything wrong with it?
No, sir. Right. Right.
Like I have a series of numbers, each of them I'm going to multiply by 2. And once I add them up, the net effect is without multiplying, I add them up and then the final answer I multiply by 2. It's going to give me the same thing. Is it not?
Correct, sir. Correct.
Yes, sir. Same answer.
Yeah. Somebody raise your hand now. Can you come up with your question? I could not make out who raised your hand now. Okay, let me continue now. Now this H part, I'm leaving it here in each individual step. I'm doing it once for all right at the bottom. Now, I'm again going to multiply the product for area with the lever. Like how I have done it in the geometric shape, area into lever. Here I'm doing it with product for area into the lever. So 1A into 0, the net answer becomes 0. 4B into 1 will become 4B, product for moment. 2C, which was nothing but ordinate into Simpson's multiplier. This product of area multiplied by the lever 2 will become 4C. Then it becomes 12D, 4E. I add them up all together and finally just once multiplied with H, which is part of your lever. Is that understood?
Oh, yes, sir. Understood.
Yes.
Good.
Yes, sir.
Now, going back to this final calculation, for getting the area or volume, which we have seen up to last class, it is H, which is the common interval, into the Simpson's multiplier, Simpson's constant into SOP. Here we have two SOPs, so I just to differentiate them, I call them SOP1, which is for area, and SOP2, which is for moment. Now, why do I have to use this 1/3, which is the Simpson's constant? Because of the Simpson's multiplier being part of my answer. And because this Simpson's multiplier continues to the moment also, for moments also I have to remove those multipliers by using the Simpson's constant, which is 1/3. Are you all clear? So moment we have H, which is not part of that SOP2. SOP2, that sum into H is separate. To club this entire shape, I need to multiply the common interval also. Otherwise, I had only ordinates ABC. Are you clear on this? So what we have is H into Simpson's constant into SOP2. This will give me my moments. And finally, moments by area will give you the centroid. Are you clear up to this step? Like how I told you here. Total moments by the total area will give you the combined centroid. That's what we did for geometric shape also. I'm just repeating that here. The procedure is very similar. Total moment by total area will give you the centroid. But from where will you get the centroid of that bulkhead?
So from a fixed axis.
From the reference axis, which
From
I
From
stopped.
A. Yeah, from A, sir.
From A. Perfect. The reason is I've taken the entire lever from A. Is it not?
A. Yeah, because A is 0 here. If you want to take from E, then E should be 0, sir.
Perfect. If I want the centroid of this bulkhead from bottom, I should have started from E 0, 1, 2, 3, and 4. Are you clear? That means I have taken the levers from the bottom. So you will get the centroid from bottom in that case. So from where I take 0H, you will get the centroid of that shape from that axis, that ordinate. Are you clear?
Clear.
Okay, we will go through one or two more examples. Probably you'll get a better idea. Now, I'm going through this last part of this equation. Now, why I have got this value is
H and 1/3 will be cancelled each other.
exactly because centroid is nothing but moment by area. which is nothing but this equation by this equation. So where h and 1 by 3 both will get cancelled in the numerator and denominator. So what is left over is just SOP2 by 1. Is it clear? It's more simplified. Any doubt so far? Let's go to the second part. Here what I have is 6 ordinates. Which rule do I use? Remember what we did
Combination of
last
1 and
time?
3.
I have no choice, but I have to use a combination of rules. And I told you rule 3 is the least preferred, so I prefer using 1 and 2 where I'm able to use it. So because it's 6 ordinates, I have 1, 4, 1 covering area between ordinate A and C. And I'm repeating that because otherwise the C ordinate has to be overlapped. So 1, 3, 3, 1, which is right up to the 6th ordinate. Look at the product for area 1A, 4B, 1C. And since I have to take the sum of product separately because I'm using 2 different rules. For 1, 3, 3, 1, I do it separately. 1C, 3D, 3E, and 1F. And both these sums, I have to keep it separately because both of them have different Simpson's multiplier. I have to use different Simpson's constant to be able to get off the multipliers from my answer. So I cannot add these two sum of products. Is that clear why I have to leave it separate?
Captain Anand, there are a couple of queries over here in the chat.
Okay.
Can I?
Yeah.
Okay, the first one is from Muthuswamy Muthayan.
Yes.
He wants, sir, please repeat the momentum formula.
Okay. I think probably he wants for the geometric shape. Now, when we have multiple shapes, geometric shape, what we are using is moments formula to combine these shapes together. It can be any number of shapes. I can just keep adding it on the left hand side. So here I've just taken an example of 2 different shapes. Taking moments of areas about bottom, I have to define the reference axis first. Area A, which is rectangle, triangle in this case, plus centroid of A, this is called lever, plus area B, which is rectangle, into the centroid of B, this 8.5, which is also called the lever, is equal to total area into the combined centroid. Does that answer your question? The same thing we are going to apply here in this curvilinear shape. I first define the axis. Since I want from top, I take this ordinate A. I need to know where is the centroid of this ordinate from the reference axis. Since both of them coincide, that means the distance is 0. H being the common interval, ordinate B's centroid is h meters away, ordinate C's centroid is 2h away, so forth. Does that answer your question?
Captain Anand sir, moderator here.
Yes.
Mr. Tarun Dadwal had raised one question. He having doubt that you have said that we are taking distance of the center from the axis for moment then in formula. Why we are retaking Simpson constant and multiplier?
Now the reason is without using the Simpson's multiplier, I cannot club the shape, integrate the shape. So this integration has to be done in all the stages, not just for area, even for the moments. I need to integrate them. That is why the Simpson's rule has to be used right up to the moments. Does that answer your question?
Fine, like sir, fine, right, sir.
Yeah. Because if I stop the multiplier here, I cannot combine this shape for getting the moments of the whole shape. Right, next question.
The next question, Mr. Sambat Kumar Ilango had raised that the lever is always 0, 1, 2, 3, 4, 5 or it is like common distance.
No, we will be going a little further and seeing how these levers can vary a little. But as of now, just understand that if I have all these ordinates parallel to the reference axis, the levers will be like this. The levers will be like this only. But okay, I can also play around a little bit. Like for example, let me draw and show you.
So we can also see from where the reference we are taking this terminal.
Now can you repeat?
So we can also say from where the reference point axis we are taking, the zero starts from.
Zero starts from there. For example, I'm taking a reference axis here where this distance is, let's say, 5 meters. Now, if I want to get the centroid of this entire bulkhead from this imaginary line which I have drawn, I can take levers from there also. So what is the distance of ordinate A from the reference axis in this case?
5.
5. So in this case, I am going to replace this by 5. Are you clear? Because that is the distance of the centroid of ordinate A from the reference axis. So what will be the distance of lever for B?
10.
5 plus h.
5 plus h. I'm not saying h is also 5. The distance of that imaginary axis is 5 meters from the top of the tank. So 5 plus h, then it will become 5 plus 2h, 5 plus 3h, 5 plus 4h.
So, but in this case, you cannot add h to A, no, sir. Like what you did in the next slide. 0h you did, no, but you cannot do this in 5h, right?
No. If you see here, the lever is going to be 5. That's all. So when you do here, yeah.
So you have to multiply the h over the lever only. So you cannot do that in the product of moments. What you did here, like sum of h.
No. You cannot take that h common here.
Yeah, that's all.
Because for the first ordinate, it is just 5 meters. The second ordinate, whatever is h, you have to add that with 5. So this common h factor will not come in that case. Correct. Because I'm going to take the distances of each axis directly, not in multiples of h. That's very right. Any other questions?
No questions.
Fine. Okay, what I have shown here is, in case I'm using rule number 2, then it becomes so Simpson's multipliers 1331 overlap 1332. Then I have product for area, levers 0h, 1h, 2h, 3h, 4h, 5h, 6h. So I get product for moment where I leave this h because I'm going to take it common here. I add them up all together and finally multiply it with h just once, which saves me a lot of time. And then area or volume is equal to h into Simpson's constant, in this case 3 by 8 into SOP1. Moment will be h into 3 by 8 into SOP2. That part is clear?
Yes,
Now
sir.
coming back to that 6 ordinates where I am forced to use 2 rules. First I have got
Yes, sir.
ABC under rule number 1. From C to F, I use rule number 2. Get the product of areas separately. I cannot add the two SOPs what I get for areas because each one has different multiplier. So I have to use respective constants to get the correct areas. That is why if you see here, I have used for area A, which is between A and C, the top area. For that, since I have used rule number 1, I use the constant 1 by 3 to get the area. Area B, which is the shape, the portion between C and F. There, since I have used rule number 2, multiplies 1331, I use the constant 3 by 2, 3 by 8 to get the area of shape B. And finally, once I get the two areas, then I add them. So is it clear why I should not add SOP 1A and SOP 1B?
Yes, sir, got it, sir. They both have different Simpson
Constants,
Multiplies
okay.
and hence different constant. Correct. The same thing I'm going to do for getting the moments. So levers 0H, 1H, 2H, 3H, 4H, 5H. So when I multiply for shape A, 0, 4B, 2C. Oh, sorry. This 2C is supposed to come here. It has to be separately kept, like how we did for area. You see here, this C, what I got here, it's just slightly misplaced. So this 2C has to come here. So 2C, 9D, 12E, 5F are the moments for shape B. I add 0, 4B, 2C so that and then of course multiply it with H so that I get SOP2 for shape A. The same way I repeat that step for rule 2. Sum into H will give me SOP2 for shape B. Remember, SOP1 is for area, SOP2 is for moments. So what I do here, like how I've calculated the respective areas, the same way I apply the two constants and I get moments for area A and moment for area B. Now, just like I have added for area, I'm going to repeat it for moments also. I get the total moments. Total moments by total area will give you the centroid from top. Why I have mentioned from top here? Because I took the lever 0H from top. So I will get the centroid of this combined shape from top only. Are you clear so far?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
There is one more way of calculating this. Remember what we did here? SOP2 by SOP1 will give you centroid. All are able to see this? The same thing what I do here is,
So one question.
Yeah.
This in the product of area, the sum into H you mentioned actually for SOP1.
Correct, because that is part of the lever. See, this H is for combining the area between A and B. Two ordinates A and B will not represent the total area between A and B, is it not? Because in the since this table what I have taken is ordinate A, B, C, D only. How are you going to get the total area between A and B? I have to multiply it with the common interval, only then the area is complete. So that h what I have here is for getting the total area between A and B. The same thing I have to repeat it for moments. This what I have here is going to get the total area between A and B. But the h which I put here is part of my lever.
Yeah, that understood, sir. But in the column before, product of area, where you mentioned the sum into h instead.
Oh, the previous one? This one?
No, sir. The same slide he is asking for the product of area. You have mentioned sum into h, which should come only sum. So SOP, the area
No.
h into 1
Have
by
I
3.
put h here? The lever is supposed to be 0h, no?
Sir, not that column, sir. The previous
The
column.
before one,
That is the third
product of
column.
area columns.
In the
In the area column, there is no h.
Sir, but you have written
Oh,
sum into h.
sorry. Yeah, that's wrong. Correct. I made a mistake there. So in the area column, there is no h. This is not there.
The h can be there. Sum into h into 1 by 3, sir. SOP into h into 1 by 3, simply.
Yeah, because I've repeated it here, no?
Yes.
So I cannot put it in both places.
Yeah,
Correct.
that's right. So that's why confused. Thank you.
So only one has to be there. Correct. Very rightly pointed out. So either I put in the column 3 or I put it in the final equation, only in one place. Good, well pointed out. Now I'm trying to explain this second part, how I am doing. Now since I have taken the lever from top, SOP2 by SOP1 for shape A, when I do, I will get the centroid of the shape A from top. The same way, SOP2B by SOP1B will give you the centroid of the B portion from top. Are you clear on that?
Yes, sir.
Why? Because I have taken the lever without any interruption. The lever is the same. So the lever is just a continuation. So that is why for both the shapes, I will get the centroid from top. Now what I do, like how I did for the rectangle triangle, area A into centroid A plus area B into centroid B is equal to total area into the combined centroid. Are you clear on that? This is also another way of doing it. Whichever you are comfortable, you can follow that. Any doubts so far? Now, remember last time we saw something called vertical ordinates, where the ordinates are perpendicular to the reference axis, like tank top. So the difference between the two diagrams which we have seen is, in this case, each of the ordinate is parallel to the reference axis. Whereas the same is slightly different here. The ordinates are perpendicular to the reference axis. Now there is a slight change in the lever. Remember what I took for the previous bulkhead shape also? I took the centroid of each ordinate from the reference axis. So for ordinate A it was 0, for ordinate B it was h, then 2h, 3h. But here it's not the same. From this reference axis, what is the centroid of this ordinate A from top, from the reference axis? Anybody?
By 2?
Yes, A by 2, which is what I have written there. What will be the centroid of ordinate B from the reference axis?
B by 2.
Perfect. So the series goes on, C by 2, D by 2, E by 2. Yes. So what is common here?
By 2.
By 2.
1 by 2.
1 by 2 is common. Whereas in the previous case, it was H which was common. Is it not?
Yes, sir.
Yes, sir.
Anybody not clear on this? No. Okay. Let's go to the calculation part. Basic 5 ordinates I have taken. Is there any difference so far until I come to product of area? Is there any difference between horizontal and vertical ordinate for getting area? Look at the calculation and tell me whether it's horizontal ordinates or vertical ordinates. Any change in method for calculating area? You just took ordinates, Simpson's multiplier, product for area.
Sir, in C, what it is written simply C.
2C.
2C, right?
Again, I missed out. Typo error. It's 2C.
Okay, okay.
Yes,
Okay,
it's
okay.
typographic error. Yes, it's typographic error. Correct.
Product you have mentioned correctly, 2C square.
For moments, I've brought it correct. So the levers, the same thing. Instead of putting A by 2, B by 2, C by 2, I've taken this 1 by 2 common here instead of like horizontal ordinates, how I took H. Here I took 1 by 2 coordinate common.
Yes, understood.
Understood?
Yes,
No?
sir. It came in the bottom.
Perfect. Yeah. So look at the product for moment here. Area as ordinate A itself is the lever, so the product for moments become A square. So I'm just multiplying this column 3 with column 4. Only then I get the column 5. Is everything understood till this table part?
Yes, sir.
Right. Let's go to the calculation part. Area or volume, H into 1 by 3 into SOP1. Absolutely no change, whichever type of ordinate it is. Moment is equal to H into 1 by 3 into SOP2. But here the SOP2 is having this number 1 by 2. So moments by area is equal to centroid. SOP2 by 1 will also give you the centroid. But this centroid will be from where? Anybody? The centroid of the combined bulk of this entire bulkhead will be from where?
From the top of the bulkhead, sir.
From the top of the bulkhead.
Reference axis.
From the reference axis. What if by chance instead of top I want the centroid of this bulkhead from bottom?
Still the same.
No, we cannot do it. The reason being
A
and E. Are they touching that ordinate?
No.
Sorry, reference axis. No. That means I cannot get the centroid from the reference axis like how I got from top. So it cannot be done. So you have to calculate the total centroid, total bulkhead centroid from top. And then from the total height of the bulkhead, can you subtract the distance? Because centroid is only 1 point. If you get the distance from top, what is the centroid? If I subtract from the total height, will I not get from the bottom?
yes, sir.
Right, sir.
So don't get confused. There is no way I can take levers from bottom because ordinate E and A are not touching the ordinates. So I do the same way as I've done from top, get the answer, and finally I subtract from the total height. Because centroid is one common point that cannot change. So whatever is the distance from top, if I multiply it with the total height, I will get the distance from bottom. Clear on it?
Captain Anand sir, moderator here.
Yes.
One doubt raised by Mr. Sambat Kumar Elango.
Yeah.
Please confirm that in simple terms, lever is the distance of centroid of each ordinates from reference point. Is it right?
Correct. Very true. That's very correct. It's the distance from a fixed reference axis. Please remember, in calculating the kg of a ship, we use moments formula where W into kg is called vertical moment. So there it is the distance of center of gravity of that weight from the keel. That is also called lever. So lever is nothing but a distance from a fixed reference axis. That's all, as simple as that. It could be applied in any condition. Distance from a fixed reference axis. Any other doubts, moderator?
No doubt, sir. 8 minutes more.
8 minutes more. Oh, yeah, thank you. So any doubt in this calculation for vertical ordinates? The basic procedure has not changed. The only change is in the lever. Okay. As of now, I don't want to get into rule 3 centroids because with the remaining time I may not be able to explain that satisfactorily. So I will push it for the next session. But instead, what I want to do is I want you to see an actual calculation.
Sir, if possible, one calculation on vertical ordinates. Sir.
Yeah. We'll see that. Yes. Can you see this question? 12-meter high vertical bulkhead has the following equally spaced horizontal ordinates commencing from top. The tank is pressure up with salt water to a head of 2 meters. Calculate the thrust on the bulkhead and the position of, okay, the center of, not required now. Now remember, this tank is pressed up to a head of 2 meters. So what I have here is I have taken the levers from the tank top only. Can you see here 0h, 1h? That means I have taken the reference axis here only. All are able to see this? So 0h, 1h up to 6h I have taken. So 7 ordinates, so I use rule number 1. Product for area, the lever is 0h, 1h. And product of moment. What I've done is I've kept this h common. I've not used that value. Even though I know the h value is 2 here, instead of wasting time multiplying each by 2, I keep this h final as it is. All I've done is I have just added 34, 32.8, 96, 60.8, 142, 36. That comes to 401.6 multiplied by h. We will just calculate the thrust on the bulkhead. Now, what is the formula for calculating thrust?
Pressure
into area.
Pressure into area.
Pressure into area. Pressure is depth into density. What is that depth? Depth means it is the depth of the centroid of that bulkhead from the surface of the water. Are you clear? So I need the centroid of this bulkhead. Now, even though I need the centroid of this bulkhead from water surface, which is right here, are you able to see my pointer? There is a 2-meter head. All are able to see my pointer?
Yes, sir. Yes, sir.
Yes, sir.
Yeah. Okay. Instead of taking the lever from the water surface, that is right on top, I have taken it from the tank top only. So that's why it is still 0H, 1H, 2H. So I finished the columns. Area, any doubt? One by 3 into H. I just put it as H by 3 into SOP1. H is 2. So the area comes 93.87. SOP2 by 1 will give you the centroid. So the centroid of the bulkhead from the top of the tank is 5.707. Remember, SOP2 also has this H. So I put this 2 here. But for calculating thrust or pressure, from where I need the centroid?
Water.
From the water surface. So if I add 2 meters, which is the head, will I not get the centroid of that bulkhead from water surface?
Yes.
Correct. Correct.
Which is what I've used for calculating the thrust. Depth into density is pressure multiplied by area will give you the thrust. So area is 93.87, which we got here. Into the centroid depth from water surface is 7.705. Into the density, I've taken it as salt water. So this is what you get the thrust on the bulkhead. Any doubt on this?
So can you please show the diagram?
Height of the bulkhead is 12 meters. 7 ordinates. That means 6 intervals. So 12 by 6 will give you common interval of 2 meters.
Okay, sir. Okay, sir.
Clear?
Yes, sir.
Clear about this table of calculation? Clear? Then for thrust, I need the centroid from water surface, not tank top. But because I've taken 0H, 1H, that means I've taken the lever from top of the tank. 5.705 represents the centroid from the top of the bulkhead. Since I need from water surface for thrust, I add that head of 2 meters. Is that understood? Can we go to the next calculation?
That HD is the head, sir.
Not head. It is the center. D is the centroid from the head. Or I can replace it by centroid from water surface.
Thrust is pressure into area, right, sir?
And pressure is depth into density.
Perfect, perfect. Okay.
So, sir, could you go up one slide up, sir?
This one?
Yes, sir. Yes, sir.
See, if I wanted the final centroid 7 points, what is it? 7.705 directly, instead of in terms of H, I could have taken 2, 4, 6, 8, 10. In that case, directly I would have got from water surface, the lever.
Correct, correct, correct. Yeah.
Yeah, okay, thank you, sir. Thank you.
Can we go to the vertical ordinate? The vertical ordinates of the bulkhead measured downwards from the horizontal deck at equal intervals I forgot to give the breadth of the bulkhead. Find the position of the centroid from the tank top. That means I want it from here, top of the tank.
What will be the H value, sir?
Yeah, H value, let's see here. Total H value, I forgot. I think it's 1 meter. That means the width of this bulkhead is 6 meters.
Yes, 6 meters.
Can you repeat?
There's something wrong in the interval, sir.
Correct, sir. 6 meter. It should be 6 meter. So 6 by 6 should come H is 1.
Yeah, if you see here, the final answer is 36 for area. So unless it is 108 by 3, I cannot get this 36, is it not? So
Yes.
H has to be 1.
Yes.
So that's how I worked backwards. So the bulkhead, because it is 7 ordinates, that means 6 intervals. So the width of the bulkhead has to be 6 meters.
The question is different, sir.
At equal intervals, I should have mentioned this. This is what I should have mentioned. Yeah.
Yes, sir.
No, in the question there are only 6 ordinates actually. So 3, 5,
No, in 7 ordinates.
3, 5, 7, 8.5, 7.5. Oh, that is 7 and 5.
7 and 5.
That should be 7 and
correct,
5.
Correct.
Okay, sir.
It's comma. Correct. That's right, sir. So that's how the working goes. So that 1 by 2 comes here.
Sir, so here H is 1, correct? Sir?
Correct. So you can get the centroid directly as SOP 2 by 1 also. 703 into 1 by 2 by 108.
Sir, can you go a little up, sir? That calculation part.
This one?
Yes.
Sorry for the interruption, Captain Anand, sir.
Yes.
Already time is up.
Okay. Fine. We'll wind up with this.
Question once again.
Question? Vertical ordinates of the bulkhead measured downwards from the horizontal deck.
Thank you, sir.
Yes.
Sir, just a small doubt. The lever you have mentioned as 3, 5, 7, 8.5 should be 3 by 2, 5 by 2. Or...
Yeah. Which is why I've put 1 by 2 here. Can you see here?
Okay, sir.
Correct. I left off here, but have included there. Actually, the right practice should have been to put 1 by 2 here also, and then carry forward in the bottom in SOP2. Correct.